You are trapped, not metaphorically, not philosophically, physically trapped in the most absolute prison imaginable. The walls of this prison are so far away that light would take billions of years to reach them, and yet you cannot escape. You will never escape. Neither will your children, nor their children, nor any descendant of humanity across all future generations. The prison is the observable universe, and the bars are made of physics itself. This isn't pessimism or existential dread. This is what cosmology has revealed over the last century of observation. The universe is expanding, but not just expanding, accelerating its expansion. And this acceleration creates an absolute, inescapable horizon beyond which nothing can ever reach us, and which we can never reach. Galaxies are receding from us faster than the speed of light. Not because they're moving through space at those speeds, but because space itself is expanding between us and them. And as space expands, more and more of the universe disappears beyond a cosmic event horizon, winking out of existence from our perspective, gone forever. We are confined to an island in space-time, an island that is shrinking. Right now, as you watch this, the accessible universe is getting smaller. Galaxies that we can still theoretically reach today will be forever beyond our grasp tomorrow. The prison walls are closing in, but it's worse than that, because the expansion isn't the only constraint. There are other walls to this prison, other limits built into the fabric of reality that ensure we can never truly explore the cosmos, never spread indefinitely, never escape the boundaries that physics has imposed. In this video, we're going to explore every dimension of this cosmic confinement: the speed of light, the expansion of space, the thermodynamics of black holes, the arrow of time, the quantum limits of information and energy. Each one is a wall of the prison. Each one is inescapable. And by the end, you'll understand why we live in the most beautifully constructed, most perfectly secure prison that could possibly exist. Let's begin. Section 1, the speed of light, the first wall. The most fundamental barrier to cosmic exploration is the speed of light. 299,792,458 meters per second. Approximately 300,000 kilometers per second. About 186,000 miles per second. This is not just fast. This is, according to special relativity, the absolute maximum speed at which anything, information, matter, energy, causality itself, can travel through the universe. You cannot go faster than light. This is not a technological limitation that better engines might overcome. It is woven into the geometry of space-time itself. The faster you move through space, the more energy it requires. As you approach the speed of light, the energy required approaches infinity. You would need infinite energy to reach light speed if you have any mass at all. So light speed is the limit, and this creates our first prison wall. The Milky Way galaxy is about 100,000 light-years across. That means light takes 100,000 years to cross from one edge to the other. If you built a spacecraft capable of traveling at 99.9999% the speed of light, an engineering feat so far beyond our current capabilities that it might as well be magic, it would still take you over 100,000 years of external time to cross the galaxy. From your perspective on the ship, thanks to time dilation, the journey might feel shorter. At extreme relativistic speeds, time slows down for the traveler relative to the outside universe. But the external universe still ages by those 100,000 years. When you arrive at your destination, everyone you knew when you left is long dead. Civilizations have risen and fallen. The world you departed from no longer exists. And that's just within our own galaxy. The nearest large galaxy to the Milky Way is Andromeda, about 2.5 million light-years away. At light speed, that's a 2.5 million year journey. The entire span of human evolution, from the first stone tools to now, has been about 2.5 million years. That's how long it would take to reach our nearest galactic neighbor at the absolute maximum speed the universe allows. The observable universe is about 93 billion light-years across. To reach the edge, to see what lies at the cosmic horizon, would take 46.5 billion years of travel at light speed. The universe is only 13.8 billion years old. It hasn't even existed long enough for light from the edge to have reached us yet, let alone for anything to have traveled there and back. This is the first dimension of the prison, distance itself, combined with the absolute speed limit, creates gulfs of space so vast that crossing them requires timescales that exceed the lifetime of stars, perhaps the lifetime of galaxies themselves. But humans are creative. We solve problems. What if we didn't need to travel at light speed? What if there were shortcuts? This brings us to the question of wormholes, warp drives, and other speculative faster-than-light solutions. And this is where physics becomes unforgiving. Wormholes, hypothetical tunnels through space-time connecting distant points, are permitted by the equations of general relativity. But every solution to Einstein's equations that produces a traversable wormhole requires something called exotic matter with negative mass-energy density. This is matter that repels rather than attracts gravitationally, matter that has never been observed, that violates every known principle of quantum field theory, and that almost certainly does not exist. Even if exotic matter did exist, the wormhole solutions are unstable. They collapse the moment anything tries to pass through them. Keeping a wormhole open would require infinite energy continuously applied. Not metaphorically infinite, mathematically infinite. The Alcubierre warp drive, the closest thing to a scientifically serious proposal for faster-than-light travel, faces the same problem. It requires exotic matter with negative energy density to compress space in front of a spacecraft and expand it behind. The total amount of exotic matter needed, even for a small spacecraft, would have a mass energy equivalent to the mass of Jupiter. And that's the most optimistic estimate. No known physics allows us to circumvent the speed of light. Every loophole closes when you examine it carefully. Every proposed solution requires materials or energies that don't exist and likely cannot exist. We are bound by the speed of light. And because we are bound by the speed of light, we are bound to a small region of space confined by the sheer scale of cosmic distances. This alone would be enough to call the universe a prison, but it's just the beginning. Section 2. The expansion of space. The closing walls. The speed of light creates a barrier, but if space were static, that barrier would at least be stable. Given enough time, you could potentially reach anything, no matter how distant. Launch a generation ship. Let it travel for millions of years. Eventually, it arrives. But space is not static. Space is expanding, and this expansion transforms a difficult journey into an impossible one. In 1929, Edwin Hubble made an observation that changed our understanding of the cosmos. He noticed that distant galaxies are red-shifted. Their light is stretched to longer, redder wavelengths, and the farther away a galaxy is, the greater its redshift. The only explanation that fits the data: galaxies are moving away from us, and they're moving away at speeds proportional to their distance. The farther away a galaxy is, the faster it's receding. This is not because galaxies are flying through space away from us. It's because space itself is expanding. Every point in space is moving away from every other point. Galaxies are embedded in this expanding space, carried along by it. Here's the critical point. This expansion has no speed limit. The expansion of space is not bound by the speed of light. Galaxies can recede from us faster than light because they're not moving through space. Space is expanding between us and them. Right now, there are galaxies receding from us at twice the speed of light, at 5 times the speed of light, at 10 times the speed of light. The recession velocity depends only on distance, and it scales without limit. This creates something called the cosmological event horizon. It's the distance beyond which objects are receding faster than light. Anything beyond this horizon is causally disconnected from us. Light from those regions will never reach us. Signals sent to them will never arrive. It is as absolutely inaccessible as the interior of a black hole. Currently, the cosmological event horizon is about 16 billion light-years away. But here's what makes this a prison rather than just a boundary. The horizon is moving inward. As the universe continues to expand, and that expansion continues to accelerate, driven by dark energy, fewer and fewer galaxies remain within our reachable sphere. Galaxies that are currently just inside the horizon will cross it, and once they cross, they're gone. Forever. No signal we send will ever reach them. No light from them will ever reach us. In about 100 billion years, all galaxies outside our local gravitationally bound group, which includes the Milky Way, Andromeda, and a few dozen smaller galaxies, will have crossed the cosmological horizon. An observer in that future universe will look out and see only their local group surrounded by perfect infinite darkness. The rest of the universe will have literally disappeared. But it's worse than that, because dark energy, the force driving the accelerated expansion, appears to be constant. This means the expansion will continue forever, accelerating forever, until space itself is torn apart. This is called the Big Rip. If dark energy continues to strengthen or even remains constant, the expansion of space will eventually become so extreme that it overcomes not just the gravitational binding of galaxy clusters, but of galaxies themselves, then solar systems, then planets, then molecules, then atoms. Everything will be ripped apart. The universe will expand so fast that particles will be torn from each other, unable to interact even electromagnetically. Matter itself will cease to exist in any meaningful form. Even if dark energy doesn't lead to a big rip, if it remains stable and simply continues expanding space at an accelerating rate, the end state is thermal death. All stars burn out. All matter decays or falls into black holes. All black holes evaporate. The universe approaches maximum entropy, a state of perfect uniformity where nothing can ever happen again. The expansion of space is not just a barrier, it's a countdown. The walls are closing, the accessible universe is shrinking, and there is no escape velocity. No matter how fast you travel, you cannot outrun the expansion of space itself, because it's the space you're traveling through that's expanding. We are not just confined to a region of space. We are confined to a shrinking region in a universe that is fundamentally hostile to exploration, doomed to end in darkness and cold. Section 3. The Arrow of Time, the One-Way Corridor. Let's talk about another dimension of the prison, one that's so fundamental to your experience of reality that you probably don't even notice it. You're moving through time in only one direction, and you can't stop. You can't slow down. You can't reverse. Time has an arrow. It points from past to future. Entropy increases. Eggs break but don't unbreak. People age but don't unage. The universe evolves from ordered states to disordered ones, and never the reverse. This is the second law of thermodynamics, and it is one of the most ironclad laws in physics. In any closed system, entropy, roughly speaking, disorder, increases over time, or at minimum, stays the same. It never decreases. Why does this matter for the prison metaphor? Because it means time travel to the past is almost certainly impossible. The arrow of time is not just a psychological illusion. It's built into the thermodynamics of the universe. To reverse time would require reversing entropy, taking a high entropy state and returning it to a low entropy state without inputting energy from outside the system. And the universe, by definition, has no outside. It is the closed system. There's nowhere to draw energy from to reverse entropy globally. General relativity does permit solutions where closed time-like curves exist. Paths through space-time that loop back on themselves, allowing travel to the past. The most famous are the Gödel metric and certain configurations involving rotating black holes. But every single one of these solutions has the same problem. They require conditions so extreme, so exotic, and so causality violating that most physicists believe they represent mathematical curiosities rather than physical possibilities. They require infinite rotating cylinders of matter, or black holes spinning faster than the laws of physics allow, or other configurations that cannot exist in our universe. Even if you could create a closed time-like curve, you run into paradoxes. The grandfather paradox is the famous one. If you go back in time and prevent your grandfather from meeting your grandmother, you're never born. But if you're never born, you never go back in time. Contradiction. There are proposed resolutions, many worlds interpretations, where changing the past creates a branching timeline, or self-consistency principles where the universe won't allow paradoxes to occur. But none of these are experimentally testable, and most require speculative physics that goes beyond established theory. The most likely answer is the simplest. You can't travel backward in time. The arrow of time is absolute. The past is fixed. The future is the only direction available. And this creates another wall of the prison. You are trapped not just in space, but in time. You exist at one moment, moving inexorably toward the next. You cannot revisit yesterday. You cannot skip ahead to tomorrow. You are confined to the present, moving through it at a fixed rate, 1 second per second, unable to deviate. Even relativistic time dilation doesn't let you escape this. When you travel at high speeds, time slows down for you relative to the outside world. You can age less than people who remain stationary. but you don't travel backward in time. You don't jump forward in someone else's reference frame. You just experience time at a different rate. It's still one way, still inexorable, still a corridor with no exits, no side doors, no way to turn around. Section 4. The information paradox. You cannot be copied. Here's a constraint you might not have considered, but it's one of the most absolute limits in all of physics. A limit that applies not just to travel, but to your very existence. You cannot be perfectly copied. This comes from quantum mechanics, specifically from the no-cloning theorem. In quantum systems, it is mathematically impossible to create an identical copy of an unknown quantum state without destroying the original. Why does this matter? Because you are a quantum system. Every particle in your body, every electron, every atomic nucleus exists in a quantum state that contributes to what you are. If you wanted to create a perfect copy of yourself, perhaps to transmit your consciousness across vast distances, or to back yourself up, or to achieve a form of immortality, you would need to copy your quantum state perfectly. You can't. Physics forbids it. Now, you might argue, can't you just measure the quantum state, record the information, and reconstruct it elsewhere? That's the basis of quantum teleportation, which is a real phenomenon. But here's the catch. Measurement destroys the original state. Quantum teleportation works by entangling two particles, measuring one, and using that measurement to reconstruct the state in the other. But the original particle loses its quantum state in the process. The information is moved, not copied. This is fundamental to quantum mechanics. Information about a quantum state cannot be duplicated. You can move it, but you cannot copy it. For macroscopic objects like humans, the implications are profound. If you wanted to upload your consciousness, to transfer your mind to a computer or to another body, you would need to capture the complete quantum state of every particle in your brain. Tens of trillions of particles, all in specific quantum configurations. Even if you could measure all of this, you can't. The measurement would perturb the system, and the Heisenberg uncertainty principle ensures you can't simultaneously measure all properties precisely. The act of measurement would destroy the original quantum state. You would be disassembled in the process of being copied, and if you can't be copied, you can't be transmitted. No beaming across space Star Trek style. No uploading to the cloud. No backing yourself up against death. You are tied to the specific configuration of matter that makes up your body right now. If that configuration is disrupted, you cease to exist. You might be able to create something that resembles you, that has your memories and personality, but it wouldn't be you. It would be a copy, and you would be gone. This is another bar of the prison. You are locked into your physical form. You cannot escape it by transitioning to some other substrate. You cannot exist in multiple places simultaneously. You cannot preserve yourself indefinitely through copying. You are singular, mortal, and tied to matter in a way that cannot be transcended without destroying what you are. Section 5. The heat death. The final wall lets. Zoom out and look at the ultimate boundary of the prison, not the edges of space, but the edge of time itself, the end of everything. The universe is running down. Entropy is increasing, and this process is not reversible. Right now, the universe is full of useful energy. Stars burn. Galaxies rotate. Black holes accrete. There are gradients, temperature differences, density differences, concentrations of matter and energy that can do work. But these gradients are temporary. Stars burn through their fuel and die. Gas clouds disperse. Matter falls into black holes or spreads out across expanding space. Gradually, inexorably, the universe approaches a state of maximum entropy. This is called heat death, or the Big Freeze. It's the ultimate fate of the universe under current cosmological models. Here's how it unfolds. In about 1 trillion years, the last new stars will form. After that, star formation ceases because all the available hydrogen and helium has been locked up in stellar. Remnants or dispersed too thinly to collapse into new stars. In about 100 trillion years, the last stars will burn out. The smallest red dwarfs, which can burn for trillions of years, will exhaust their fuel and fade. The universe goes dark. After that, the cosmos contains only stellar remnants: white dwarfs, neutron stars, black holes, and planets. And these gradually decay. Protons, if they decay as some theories suggest, will slowly dissolve over timescales of 10 to the power of 34 years or more. Even if protons are stable, quantum tunneling effects will eventually cause matter to disintegrate on timescales of 10 to the power of 65 years or longer. Black holes evaporate through Hawking radiation. Small black holes evaporate relatively quickly. Stellar mass black holes take about 10 to the power of 67 years. Supermassive black holes take 10 to the power of 100 years or more. Eventually, after unimaginable eons, even the last black holes evaporate. What's left is a thin soup of particles spread across an expanding universe, so diffuse that they might never interact again. Temperature approaches absolute zero. Entropy reaches maximum. Nothing can happen anymore because there are no gradients left to drive any process. This is heat death. Not a dramatic end, but a slow fade into eternal, unchanging equilibrium. And this is the final wall of the prison. Even if you could somehow survive the expansion of the universe, even if you found a way to persist across cosmological timescales, even if you solved every other problem, eventually there will be no energy left to sustain you. No stars to power your civilization. No processes to extract work from. The universe becomes a cold, dark, empty void, and it stays that way forever. Time doesn't end. Space doesn't end. But the capacity for anything to happen does. And that might be worse than ending. To exist in a universe where existence is possible but meaningless, where you persist but cannot act, cannot change, cannot experience anything new. That is a kind of hell. The heat death is the ultimate prison sentence, not confinement in space, but confinement in time. The universe itself reaches a state from which there is no escape, no change, no possibility of anything mattering ever again. Section 6. The Simulation Hypothesis. Prison within prison. Now let me introduce a possibility that's both philosophically fascinating and deeply unsettling. One that adds yet another layer to the prison metaphor. What if the universe itself, with all its constraining laws, its speed limits, its expansion, its thermodynamics, is not fundamental? What if it's a construction, a simulation? This is the simulation hypothesis, most rigorously formulated by philosopher Nick Bostrom in 2003. The argument is deceptively simple. If it's possible to create realistic simulations of conscious beings, then advanced civilizations will eventually do so. And they won't create just one simulation. They'll create many, potentially billions or trillions. if that's true, then the number of simulated conscious beings vastly outnumbers the number of real conscious beings in base reality. And if you're a conscious being, probability suggests you're more likely to be simulated than real. Run the numbers. If even one civilization in the history of the universe creates 1 billion simulated consciousnesses, and there are millions of such civilizations, you end up with quadrillions of simulated minds for every real one. The odds that you're in base reality drop to nearly zero. Now, here's how this connects to the prison concept. If we're in a simulation, then all the constraints of physics, the speed of light, the expansion of space, the arrow of time, the laws of thermodynamics, are not fundamental features of reality. They're features of the simulation. They're programmed limits, deliberately constructed barriers. Why would a simulation have these barriers? For the same reason video games have barriers: to create boundaries, to limit computational cost, to make the simulated world coherent and stable. Think about it. The speed of light serves as a maximum propagation speed for information, limiting how much of the simulation needs to be computed in real time. The expansion of space ensures that distant regions become causally disconnected, reducing the complexity of maintaining consistency. The arrow of time prevents paradoxes and keeps causality flowing in one direction. These aren't bugs. They're design features. They're exactly the kinds of limits you'd build into a simulation to make it manageable and consistent. If we're in a simulation, then the universe being a prison is not an accident of physics. It's an intentional design choice by whoever or whatever is running the simulation. And there's no escape from a simulation from within. You can't break out of the matrix if the matrix is all that exists for you. The walls of the prison are not just physical laws, but the very substrate of your existence. You might think, but couldn't the simulators free us? Couldn't they change the parameters, remove the constraints? Maybe. But why would they? If we're in a simulation, we're here for a reason: research, entertainment, education, something. Changing the fundamental rules of the simulation might defeat whatever purpose it serves. Or maybe they can't change the rules without breaking the simulation entirely. Maybe the constraints are necessary to keep the simulation stable, and removing them would cause it to collapse. Either way, if the simulation hypothesis is true, we're prisoners twice over, trapped in a universe with physical constraints and trapped in a computation with no access to anything outside it. The walls are not just made of physics, they're made of code, and code can be rewritten, but not by us. Section 7. The Quantum Prison: Uncertainty as Barrier. There's another kind of confinement built into reality at the most fundamental level. One that limits not where you can go, but what you can know. And in physics, the limits of knowledge are also limits of action. This is the quantum realm, and it imposes its own set of absolute constraints. The Heisenberg uncertainty principle states that you cannot simultaneously know both the exact position and exact momentum of a particle. The more precisely you measure one, the less precisely you can know the other. This isn't a limitation of measurement technology. It's a fundamental property of quantum systems. Position and momentum are conjugate variables. They're linked by the mathematics of quantum mechanics in such a way that reducing uncertainty in one necessarily increases uncertainty in the other. The product of their uncertainties has a minimum value set by Planck's constant. This creates a profound limitation. If you want to manipulate matter with perfect precision, to build molecular machines, or to store information at the quantum level, or to control biological systems at the atomic scale, you run into an absolute wall. You cannot know enough about the system to control it perfectly. There are other uncertainty relations. Energy and time are also conjugate variables. The more precisely you try to measure the energy of a quantum system, the less precisely you can determine when that measurement occurred. For very short time intervals, energy fluctuations become large. The vacuum itself seethes, with virtual particles appearing and disappearing on timescales too short for energy conservation to catch them. These quantum limitations affect everything, even macroscopic engineering. You cannot build a perfect computer at the quantum level because quantum states are uncertain. You cannot create a perpetual motion machine because quantum fluctuations will always degrade any system over time. You cannot extract all the energy from a system because the Heisenberg principle ensures there's always residual uncertainty, residual motion, residual energy you cannot access. Then there's quantum decoherence. Quantum systems maintain their quantum properties, superposition, entanglement, only when they're isolated from the environment. The moment a quantum system interacts with its surroundings, those delicate quantum states collapse into classical states. This limits quantum computing. You can't build arbitrarily large quantum computers because the larger they get, the harder it is to isolate them from decoherence. Every stray photon, every vibration, every interaction with the environment causes the quantum information to degrade. It limits quantum communication. You can't send quantum information over arbitrary distances because it decoheres along the way. You need perfect isolation, which you can't achieve over long distances. And it limits the kinds of structures you can build. Any sufficiently complex machine operating at the quantum level will decohere into a classical system. The quantum possibilities collapse into classical certainties. The delicate superpositions and entanglements that might allow extraordinary capabilities cannot be sustained in a world of constant interaction and noise. Quantum mechanics is often portrayed as opening up possibilities. Quantum computing, quantum teleportation, quantum encryption. And it does, but it also imposes absolute limitations. The uncertainty principle, decoherence, the no cloning theorem, these are walls just as absolute as the speed of light. You cannot know everything. You cannot control everything. You cannot preserve quantum information indefinitely. The universe is uncertain at its core, and that uncertainty limits what can be done, what can be known, what can be achieved. Even at the smallest scales, the prison has bars. Section 8. The cosmological constant problem. Fine-tuned confinement. Here's something that should disturb you. The universe appears to be fine-tuned for confinement, not just confined by accident, but precisely calibrated to create the exact kind of prison we find ourselves in. This is called the fine-tuning problem, and it's one of the deepest mysteries in physics. The cosmological constant, the term in Einstein's equations that drives the accelerated expansion of space, the dark energy we discussed earlier, has a value that is astonishingly, absurdly precise. When physicists try to calculate what the cosmological constant should be based on quantum field theory, they get an answer that's wrong by about 120 orders of magnitude. That's not 120%. That's a factor of 10 to the power of 120, a 1 followed by 120 zeros. This is the worst prediction in the history of physics. But the measured value is not 0. It's small, but not 0. It's just large enough to cause the universe to expand at an accelerating rate, but not so large that the expansion rips apart galaxies and stars before they can form. If the cosmological constant were just slightly larger, say, larger by a factor of 10, the expansion would have been so rapid in the early universe that matter never would have clumped together to form galaxies. The universe would be empty, diffuse, sterile. If it were 0 or negative, the universe might have recollapsed long ago, or expansion would have been slow enough that entirely different structures formed. But it's not 0. It's not too large. It's exactly the value needed to create a universe where galaxies form, where stars burn for billions of years, where life can emerge, and where that life is trapped by an expanding cosmos that recedes faster than it can be explored. This is not the only fine-tuning. The strength of gravity, the mass of the electron, the ratio of the strong nuclear force to the electromagnetic force, all of these constants have to be within extremely narrow ranges for the universe to be habitable. Change any of them by a % or 2, and stars don't form, or atoms don't bond, or nuclear fusion doesn't occur. The universe appears to be calibrated. And one of the things it's calibrated for is ensuring that conscious beings emerge in a cosmos they cannot escape. Some physicists appeal to the anthropic principle. We observe these values because if they were different, we wouldn't exist to observe them. We necessarily find ourselves in a universe compatible with our existence. But that doesn't explain why the values are what they are. It just restates that we couldn't exist otherwise. It doesn't explain the calibration. It doesn't explain why this particular prison was constructed rather than some other configuration. Another explanation is the multiverse. Maybe there are countless universes with different values of the constants, and we happen to exist in one where the values allow for life. This explains the fine-tuning statistically. Out of infinite universes, some will have the right values by chance. But even if the multiverse is real, it doesn't change the fact that we're in this universe. A universe with specific, calibrated constraints that create a cosmic prison. A universe that seems almost designed to allow life to emerge and then ensure that life can never expand beyond a tiny bubble of space-time. The fine-tuning doesn't prove design, but it suggests that the prison is not accidental. The bars are not random. They're precisely placed, exactly strong enough to confine, but not so strong as to prevent existence entirely. Whether this is intentional design, anthropic selection, or multiverse statistics, the result is the same. We exist in a universe calibrated for confinement. Section 9, the Kardashev scale and its limits. Let's talk about what a civilization might achieve if it pushes against every wall of this prison as hard as possible. Because humans are optimistic. We believe in progress, in technological advancement, in overcoming obstacles. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, classifies civilizations by their energy consumption. Type 1. a planetary civilization capable of harnessing all the energy available on its home planet, roughly 10 to the power of 16 watts. Type 2, a stellar civilization capable of harnessing all the energy output of its star. For a star like the Sun, that's about 10 to the power of 26 watts. Type 3, a galactic civilization capable of harnessing the energy of its entire galaxy. Roughly 10 to the power of 36 watts. Humanity is currently at about 0.7 on the Kardashev scale. We use a fraction of the energy available on Earth. We're not even Type 1 yet. But let's imagine we advance. We build Dyson spheres around our star, capturing all its energy output. We become Type 2. We spread to other star systems, eventually harnessing the energy of the entire Milky Way. We become Type 3, and then what? We hit the walls. Even a Type 3 civilization cannot escape the prison. The speed of light still limits how fast you can travel or communicate. The expansion of space still puts most of the universe beyond reach. The arrow of time still marches forward. Heat death still looms in the far future. You can harvest all the energy of a galaxy and still be confined to that galaxy. You can build megastructures of incomprehensible scale and still be trapped in a shrinking bubble of accessible space-time. Some futurists have proposed Type 4 civilizations, ones that harness the energy of multiple galaxies, or even the entire universe. But the math doesn't work. The expansion of space ensures that you cannot ever control multiple galaxy clusters. By the time you reach one, others have receded beyond your reach. The Kardashev scale, for all its ambition, describes different levels of confinement, not escape. A Type 3. Civilization is just a prisoner with more resources. The prison doesn't get bigger, it gets smaller as the universe expands. You just have more tools to furnish your cell. There's a ceiling, and that ceiling is far below what science fiction imagines. No matter how advanced we become, we are bounded by the same physical laws. We cannot expand indefinitely. We cannot survive indefinitely. We cannot escape the prison. We can only make the cell more comfortable while we wait for the walls to close in. Section 10, the black hole information paradox, where information goes to die. There's another kind of prison within the larger cosmic prison, a place where the normal rules of physics break down so completely that even information itself might cease to exist. I'm talking about black holes. Black holes are regions of space-time where gravity is so intense that nothing, not matter, not light, not information, can escape once it crosses the event horizon. The escape velocity at the event horizon is exactly the speed of light. Just beyond it, escape velocity exceeds light speed. And since nothing can travel faster than light, nothing escapes. This creates what Stephen Hawking called the information paradox. In quantum mechanics, information is never destroyed. It can be scrambled, dispersed, made practically inaccessible, but the total information content of a system is conserved. If you know the exact quantum state of a system at one moment, you can, in principle, calculate what it was at any earlier moment and what it will be at any later moment. But black holes appear to destroy information. Throw anything into a black hole, a book, a computer, a human being, and all the detailed information about that object's quantum state seems to vanish. From the outside, all you can measure about a black hole is its mass, electric charge, and angular momentum. everything else is gone. This troubled physicists deeply. If black holes destroy information, then quantum mechanics is wrong at a fundamental level. The universe is not deterministic. The past cannot be reconstructed from the present. Hawking proposed a resolution in 1974. He showed that black holes aren't entirely black. They emit radiation due to quantum effects near the event horizon. This Hawking radiation carries energy away from the black hole, causing it to slowly evaporate. Eventually, a black hole radiates away all its mass and disappears completely. This solved one problem and created another. If the black hole evaporates and the Hawking radiation it emits is purely thermal, containing no information about what fell in, then the information is still destroyed. It went into the black hole, and the black hole eventually ceased to exist, and the information is gone. This paradox consumed decades of theoretical physics. The current leading solution, developed through work by many physicists, including Juan Maldacena and Leonard Susskind, involves holography. The idea is that information that falls into a black hole is not destroyed, but encoded on the event horizon in a scrambled form. When the black hole evaporates, the information is released in the Hawking radiation, though in such a scrambled state that it's practically impossible to decode. This is probably correct. Information is conserved. But here's what matters for the prison metaphor. The scrambling is so extreme that the information becomes effectively irretrievable. If you fall into a black hole, the information that constitutes you, your memories, your consciousness, your identity, gets encoded on the event horizon and then released as Hawking radiation billions of years later, in a form so scrambled that no process in the universe could reconstruct you from it. You're not destroyed, but you're scattered beyond any possibility of recovery. Your information persists, but you don't. And black holes are everywhere. The Milky Way has a supermassive black hole at its center. Every large galaxy has one. Stellar mass black holes pepper the galaxy, the remnants of massive stars that collapsed. In the far future, as stars die and matter decays, black holes may be the dominant structures in the universe. They are information traps, prisons within the prison, regions where the normal escape routes, the assumption that you can always in principle reverse a process, recover what was lost, don't apply. Once you cross an event horizon, you're in a space-time region from which no information can reach the outside. You're cut off from the rest of the universe, not just practically, but absolutely. Even if you lived for an infinite time, even if you had infinite resources, you could never send a message out. The future light cone of any event inside the black hole never intersects the future light cone of any event outside. You are isolated, causally disconnected, in a prison so absolute that not even light can carry word of your existence to the outside world. Section 11. The observable universe boundary. Beyond sight, beyond reach. Let me make the scale of the prison concrete with numbers that should make you uncomfortable. The observable universe, the region from which light has had time to reach us since the Big Bang, is roughly 93 billion light-years in diameter. That sounds enormous. It is enormous. It contains at least 2 trillion galaxies, each with billions of stars. But the universe is not 93 billion light-years across. It's larger, possibly much larger, possibly infinite. The 93 billion light-year boundary is not the edge of the universe. It's the edge of what we can see. Light from beyond that boundary hasn't reached us yet because the universe hasn't been around long enough for it to arrive. And due to the expansion of space, light from some regions will never reach us, ever, not in infinite time. Those regions are expanding away faster than light, and the light they emit is being carried away by the expansion of space faster than it can travel toward us. This creates two boundaries. The particle horizon, the farthest distance from which light could have reached us since the Big Bang. This is roughly 46.5 billion light years, defining the observable universe. The event horizon, the farthest distance we could ever affect or be affected by, even given infinite time. Beyond this horizon, regions are receding so fast that even a signal sent at light speed will never reach them. This boundary is currently about 16 billion light-years away. Everything beyond the event horizon is not just currently inaccessible. It is permanently, absolutely, fundamentally inaccessible. It might as well not exist for us. We will never see it. We will never reach it. We will never interact with it in any way. And the event horizon is shrinking. Right now, galaxies that are within the event horizon, that we could theoretically reach if we left today at light speed, are crossing out of it. They're accelerating past the threshold. Once they cross, they're gone forever from our potential future. Every second, thousands of galaxies cross the cosmological event horizon and become forever unreachable. Every year, tens of thousands. Every million years, billions. The prison is not static. It's shrinking. The walls are moving inward. And there's nothing we can do to stop it. By the time humanity becomes capable of interstellar travel, if we ever do, most of the galaxies we can see in our telescopes today will be forever beyond our reach. We'll look at ancient photographs from the Hubble and James Webb telescopes and know that those galaxies are now causally disconnected from us. We could send a signal at light speed and it would never arrive. We could travel at 99.99999% of light speed for 1 trillion years and never get closer. The universe is not just a prison, it's a shrinking prison. The cell gets smaller with every passing moment, and we can see it happening. We can measure it. We know exactly how many cubic light years of space pass beyond our reach every second, and we are helpless to stop it. Section 12, the Planck scale. The smallest cell. We've talked about the largest boundaries of the prison, the cosmic horizon, the expansion of space, the vast distances between galaxies. Now let's go to the opposite extreme, the smallest possible scale, the foundation of reality itself. This is the Planck scale, and it represents the ultimate granularity of space-time. The Planck length is about 1.6 times 10 to the power of minus 35 meters. That's absurdly small. The ratio of a Planck length to a millimeter is about the same as the ratio of a millimeter to the size of the observable universe. The Planck time is about 5.4 times 10 to the power of minus 44 seconds. That's the time it takes light to travel 1 Planck length. Below these scales, our current physics breaks down completely. General relativity and quantum mechanics, the two pillars of modern physics, give contradictory, meaningless answers when applied to phenomena smaller than the Planck scale. We don't have a theory of quantum gravity. We don't know what happens at the Planck scale. but we know that space-time itself becomes fundamentally uncertain, foamy, unstable. The smooth fabric of space-time that we experience at larger scales dissolves into something we don't understand. This creates another kind of boundary, a limit to how finely you can examine reality. You cannot measure a distance smaller than the Planck length with any physically realizable measuring device. The energy required to probe such small distances would be so high that it would create a black hole, destroying the very thing you're trying to measure. You cannot measure a time interval shorter than the Planck time. You cannot subdivide space-time indefinitely. There's a floor, a minimum, a fundamental granularity. This means the universe is not infinitely divisible. It's not smooth all the way down. At some scale, it becomes discrete, grainy, quantized, made of irreducible units. This is profoundly limiting. It means there are questions you cannot answer, not because we lack the technology, but because the questions become physically meaningless below a certain scale. It's not just that we can't measure certain things. It's that certain measurements don't correspond to anything real. The Planck scale is the bottom of the well, the smallest cell in the prison. You cannot burrow deeper. You cannot examine reality more closely. You hit a wall where the very concepts of space and time stop making sense. And this, too, is a prison? Not just on the cosmic scale of light years and eons, but on the quantum scale of the incomprehensibly small. There are boundaries everywhere, limits at every level, walls that cannot be breached because they're not made of matter or energy, but of the structure of reality itself. Section 13, the sociological prison. Even if physics allowed it. Here's something that doesn't get talked about enough. Even if we solved every physical constraint, even if we found a way around the speed of light, even if we stopped the expansion of space, even if we harnessed infinite energy, we would still be trapped by ourselves. The constraints that actually limit human expansion across the cosmos are not primarily physical. They're biological, psychological, and sociological. Let's start with biology. Humans did not evolve for space travel. We evolved for the African savanna. Our bodies require gravity or they atrophy. Our bones lose density in microgravity. Our muscles weaken. Our cardiovascular systems struggle. Our immune systems become compromised. Long-term space habitation causes vision problems, likely due to fluid redistribution in the skull. It causes DNA damage from cosmic radiation. It disrupts circadian rhythms. It may cause permanent genetic changes that make return to Earth gravity difficult or impossible. We can mitigate some of this with rotating spacecraft that simulate gravity through centrifugal force. But rotating habitats introduce their own problems. Coriolis effects that make movement disorienting, engineering challenges in construction and maintenance, energy costs to maintain rotation. And that's just in space. On other planets, the challenges multiply. Mars has 38% of Earth's gravity. Is that enough for human health long term? We don't know. The Moon has 16%, almost certainly not enough. Every other planet in the solar system is either a gas giant or has such extreme temperatures and atmospheric pressures that surface habitation is impossible. We would need to genetically modify ourselves to survive in these environments. We would need to become posthuman, different species, adapted for different worlds. And at that point, Are we still humanity spreading across the cosmos? Or are we fragmenting into isolated populations that diverge from each other, eventually becoming as different from each other as we are from other apes? Then there are the psychological constraints. Humans are social creatures. We need community, connection, shared culture. An interstellar generation ship would be carrying a small population, hundreds or thousands, not millions, cut off from Earth for centuries or millennia. The psychological strain of that isolation is unknown but likely severe. Depression, psychosis, social breakdown, all of these are risks. We've seen them in small, isolated groups on Earth, in Antarctica, on submarines, in remote research stations. And those groups know they'll return to civilization eventually. An interstellar crew would have no such hope. And there's the sociological problem. Who decides who goes? Who funds the mission? Who has authority over a generation ship in deep space? What if the ship decides not to complete the mission and instead establishes a colony in interstellar space, never reaching the intended destination? Earth-based authorities could not control or even communicate with an interstellar mission in any meaningful way. Light speed lag makes real-time communication impossible. A message to a ship 10 light-years away takes 10 years to arrive and another 10 to get a response. You can't govern across those timescales. This means any interstellar mission is effectively independent the moment it leaves the solar system. It's not a colony of Earth. It's a new civilization with its own culture, its own governance, its own trajectory that may diverge radically from Earth's. And if that's true, then expansion across the galaxy is not one civilization spreading, but many separate civilizations arising from a common origin and then evolving independently, perhaps becoming so different that they no longer recognize each other as kindred. Humanity, as a unified species or civilization, cannot spread across the stars. Only fragments of humanity, splinters that become something else. This is a prison of identity. Even if the universe allowed us to spread, we would not remain us. We would fragment, diverge, lose continuity. The human species is confined to a small region of space-time, not because physics forbids expansion, but because expansion itself destroys the coherence of what we are. Section 14, the Fermi paradox as evidence of the prison. There's a disturbing piece of evidence that suggests the prison is not just real, but inescapable. It comes from a question that has haunted scientists for decades. Where is everybody? This is the Fermi paradox, named after physicist Enrico Fermi, who articulated it in 1950. The logic is simple and brutal. The Milky Way is about 13 billion years old. It contains hundreds of billions of stars. Most of those stars have planets. If even a tiny fraction of those planets developed intelligent life, and if even a tiny fraction of those civilizations developed space travel, the galaxy should be teeming with evidence of extraterrestrial intelligence. A civilization capable of interstellar travel could colonize the entire galaxy in just a few million years. Even traveling at modest speeds, like 1% the speed of light. Send colony ships to nearby stars. Those colonies send more ships. Through exponential expansion, the whole galaxy fills up, but we see nothing. No radio signals, no megastructures, no evidence of stellar engineering. The galaxy appears pristine, unmodified, empty of intelligence except for us. This is the paradox. The numbers suggest civilizations should be common. The observation suggests we're alone. One possible explanation: we are alone. Life is extraordinarily rare, or intelligence is extraordinarily rare, or technological civilization is extraordinarily rare. We're the first, the only, a cosmic fluke. But there's another explanation that fits the prison metaphor perfectly, one that's darker and more profound. Maybe civilizations arise regularly, maybe intelligence is common, but maybe the prison is so effective that no civilization ever escapes its home solar system. Or if they do, they can't go far. The constraints we've discussed, the speed of light, the expansion of space, the energy requirements, the biological and sociological barriers, might be universal. They might apply to every technological species, and they might be insurmountable, not just difficult. Under this explanation, the galaxy is full of civilizations, each one trapped in its own solar system, each one looking out at the stars and seeing the same silence we see, each one confined by the same physical laws, the same barriers, the same prison walls. We don't see evidence of alien civilizations not because they don't exist, but because they're all in their own cells, unable to reach us, just as we're unable to reach them. Separated by gulfs of space that physics makes uncrossable. The Fermi paradox isn't a paradox. It's confirmation. Confirmation that the prison is real, that it's effective, and that every intelligent species discovers the same truth. You can look at the stars, you can dream of exploring them, but you cannot escape the solar system you were born in. Or if you do escape, barely, reaching a few nearby stars after generations of effort, you cannot go further. The walls close in, the expansion of space wins, the heat to death approaches, and every civilization ends the same way, isolated, confined, trapped until the universe itself ends. The great silence is the sound of a galaxy full of prisoners, each locked in their own cell, unable to communicate across the vast distances and insurmountable barriers that separate them. Section 15, The Dyson Dilemma. Survival requires confinement. Here's a paradox within the prison. To survive long-term, a civilization must accept confinement. And civilizations that refuse to accept it probably don't survive. Let me explain with the concept of a Dyson sphere. A Dyson sphere, proposed by physicist Freeman Dyson in 1960, is a megastructure that encompasses a star to capture all of its energy output. Not a solid shell, that wouldn't be structurally stable, but a swarm of solar collectors orbiting the star at various distances, collectively capturing most of the star's light. For a K2 civilization on the Kardashev scale, a Dyson sphere is the logical next step. Your home planet's energy resources are finite, solar, wind, nuclear, all limited. But your star puts out enormous energy. Capture even a fraction of it, and you solve your energy problems for millions of years. So you build a Dyson swarm, and in doing so, you commit yourself to staying in your solar system. Because building a Dyson sphere takes enormous resources. It requires dismantling planets, mining asteroids, constructing billions or trillions of individual solar collectors. A civilization that invests in a Dyson sphere is a civilization that has chosen to optimize for survival in place rather than expansion outward. You're putting all your resources into capturing your star's energy rather than into interstellar colony ships. And this is probably the rational choice. because interstellar travel is absurdly expensive and risky compared to building a Dyson sphere. A generation ship to another star might fail. It might encounter hazards we don't understand. It might arrive and find the destination uninhabitable. But a Dyson sphere, once built, provides reliable energy for as long as your star burns. For a sun-like star, that's about 10 billion years, long enough for your civilization to persist through timescales that dwarf all of recorded human history. The dilemma is this: the smarter move, the more survivable strategy is to stay home and build big. Not to expand outward, but to dig in, to fortify, to optimize your existing solar system rather than risking everything on a journey to another. And if most civilizations make this choice, if most reach the conclusion that Dyson spheres and system-scale engineering are preferable to interstellar colonization, then the galaxy fills up with civilizations that never leave home. The prison becomes self-imposed. Not because you can't leave, but because staying is the better strategy. The universe offers a trade. Accept confinement to your solar system, and you get to survive for billions of years. Reject confinement and attempt expansion, and you risk extinction. Most civilizations probably take the deal. They optimize for longevity in place. They become incredibly sophisticated within their solar systems, but never develop the capability or the will to expand beyond. The prison is not just enforced by physics, it's reinforced by rational strategy. Survival requires accepting the cage. Section 16, the consciousness constraint. You are locked in your skull. Let's zoom back from cosmic scales to something more intimate and equally confining: the prison of your own consciousness. You experience the world from a single point of view. You're locked inside your skull, perceiving reality through the narrow channels of your senses. You cannot experience what another person experiences. You cannot know what it's like to be someone else, not truly, not from the inside. This is called the problem of qualia, or the hard problem of consciousness. Why is there something it's like to be you? Why do you have subjective experience rather than just processing information without awareness? No one knows, and no one knows how to bridge the gap between your consciousness and anyone else's. You might argue, but we communicate. We share ideas, feelings, experiences through language and art and empathy. We're not truly isolated, but communication is imperfect. When you describe the experience of seeing red to someone, they hear your words and understand the concept, but they don't experience your qualia. They experience their own qualia of red, which might be completely different from yours, and you would never know. There's a thought experiment in philosophy called the inverted spectrum. What if when you look at something red, you experience the qualia that I experience when I look at something green? We've both learned to call certain wavelengths red, so we use language consistently. But our internal experiences are completely different, and we have no way to compare them. This might be true for all experience. Your pain is inaccessible to me. Your joy, your fear, your sense of beauty, I can observe the behaviors and brain states associated with them, but I cannot experience them as you do. You are fundamentally alone in your consciousness, trapped in a prison of subjective experience from which there is no escape, no parole, no visiting hours where you can truly share what it's like to be you. And it gets worse. Even your own memories are not reliable connections to your past self. Memory is reconstructive. not reproductive. You don't replay past experiences. You rebuild them from fragments. And the rebuilding is influenced by your current state, your beliefs, your emotions. The you from 10 years ago is, in some sense, as inaccessible to you now as another person. You can't relive those experiences as they actually were. You can only construct approximations, stories you tell yourself about who you were. You are confined not just to the present moment of consciousness, but to a constantly shifting, unreliable reconstruction of your own mental history. You cannot escape into memory. You cannot escape into another mind. You are locked in the here and now of your subjective experience, forever. This is a prison at the most intimate scale, not cosmic, but personal. The walls are not made of space-time, but of the very structure of consciousness itself. And they're just as absolute as the speed of light. Section 17, the economic prison, the tyranny of exponential costs. Here's a constraint that's more mundane, but equally impassable. Money. Or more precisely, the exponential increase in costs as you try to push against any of the physical limits we've discussed. Let's take spacecraft velocity as an example. Getting a spacecraft to 1% the speed of light is very hard, but potentially achievable with advanced technology. Nuclear pulse propulsion, laser sails, fusion drives. These are engineering challenges, not fundamental impossibilities. But getting to 10% the speed of light is not 10 times harder. It's more than 100 times harder. Because of the rocket equation, the amount of fuel you need increases exponentially with velocity. Doubling your speed requires quadrupling your energy. And you need to carry the fuel, which adds mass, which requires more fuel, which adds more mass, in a vicious cycle. By the time you're trying to reach 50% the speed of light, the energy requirements become civilization scale. You're talking about energies equivalent to the total energy humanity has used in all of history for a single spacecraft. And for 90% the speed of light, the energies become galactic scale. You would need to harness a significant fraction of your star's total output for years just to accelerate one ship. This pattern repeats for every limit. The closer you get to a physical boundary, the more resources you need to push incrementally closer. It's not linear, it's exponential. And exponential costs create an effective barrier, even when there's no absolute physical limit. Consider life extension. We can probably add a decade or two to the human lifespan with better medicine, diet, exercise. We might add another decade with more advanced interventions, genetic therapies, cellular regeneration, targeted treatments for aging. But adding a century? That requires solving dozens of different biological problems simultaneously. The cancers that accumulate over longer lifespans, the telomere degradation, the protein misfolding, the accumulated DNA damage. Each problem requires its own solution. The costs multiply, adding a millennium. That probably requires fundamentally re-engineering human biology at the genetic level. You're not just treating aging, you're redesigning the human organism to not age. The complexity is staggering, the costs astronomical. The same applies to energy. We can build nuclear power plants. We can potentially build fusion reactors. But building a Dyson sphere, that requires resources on the scale of dismantling planets. The energy needed to construct the collectors is enormous. The logistics are nightmarish. And building a second Dyson sphere around another star? you've just multiplied your costs by the difficulty of interstellar travel. You need to transport equipment, or raw materials, or autonomous construction systems across light years of space. The economics become absurd. At every level, the costs of pushing against the prison walls increase faster than our ability to pay them. Even if the physics allows it in principle, the economics forbid it in practice. We are trapped not just by the laws of nature, but by the mathematics of resource allocation. The prison has an economic dimension, and economics is just as ruthless as physics. Section 18, the existential prison, meaning in a bounded cosmos. Now we need to confront the psychological and philosophical implications of the prison. What does it mean for human life, for meaning and purpose, to exist in a fundamentally bounded universe? For most of human history, we didn't know about these limits. We looked at the stars and imagined infinite possibilities. The cosmos was a playground for the imagination. Endless worlds, limitless futures, dreams of expansion and exploration without constraint. Now we know better. The cosmos is bounded. The accessible universe is shrinking. The walls are real. And this knowledge changes something fundamental about how we relate to existence. Some people find this liberating. If we're trapped here, if Earth and perhaps the solar system are all we'll ever have, then we should focus on making this place as good as possible. We should care for our planet, for each other, for the civilization we can actually build, rather than fantasizing about galactic empires we'll never achieve. There's wisdom in that. The acceptance of limits can focus the mind. When you know you can't escape, you invest in making your cell livable, but others find it crushing. The dream of cosmic expansion, of humanity spreading among the stars, of our descendants exploring galaxies, of consciousness surviving the death of stars, and perhaps the end of the universe itself. That dream gave a kind of meaning to human existence. It suggested that our struggles matter on a cosmic scale, that we're building towards something vast and important. If that dream is impossible, if we're confined to a cosmic instant in a tiny bubble of space-time before the heat death, then what's the point? What does it matter what we do if the entire accessible universe is doomed, if all our achievements will be erased, if consciousness itself is a temporary accident that will flicker out in the cosmic dark? This is existential despair at the cosmological scale. Not just I will die, which is personal, not just humanity will die, which is species level, but the universe itself is a prison, and everything conscious will be confined and eventually terminated. That's a different level of confrontation with mortality. There are responses. Some philosophical traditions embrace impermanence. Buddhism, for instance, teaches that attachment to permanence is the root of suffering. Accepting that all things pass, including the universe itself, can be a path to peace rather than despair. Existentialism argues that meaning is not discovered but created. The universe doesn't owe you meaning. You create meaning through your choices, your commitments, your relationships. The fact that the universe is bounded doesn't negate the meaning you create within it. Absurdism, as articulated by Camus, suggests we should embrace the absurdity of existence in a meaningless cosmos. We're Sisyphus pushing the boulder up the hill, knowing it will roll back down. The nobility is in the pushing, not in achieving a final victory. These are valid frameworks, but they require a kind of psychological strength that not everyone has. They require accepting that the universe doesn't care about you, that your existence is cosmically insignificant, and that you should create meaning anyway. That's a hard sell for a species that evolved to find patterns, to seek purpose, to believe that their actions matter in some larger sense. The prison is not just physical, it's existential. And confronting it requires either enormous courage or enormous delusion. Section 19, the possibility of escape, or why there isn't one. Let's be honest and thorough. Let's examine every proposed escape route from the cosmic prison and see why each one fails. Faster than light travel, we've discussed this, requires exotic matter with negative energy density that almost certainly doesn't exist. Every proposed FTL mechanism violates causality in ways that create logical paradoxes. The universe appears to be structured specifically to prevent FTL travel. Wormholes, same problem, require exotic matter to stay open, unstable, would collapse the moment anything tried to pass through, would require energies that dwarf anything we could generate. Uploading consciousness. We've discussed the quantum no-cloning theorem, but even beyond that, we don't know if consciousness can be uploaded. We don't know if the pattern of information in a brain is sufficient to recreate consciousness, or if there's something about the physical substrate that matters. If consciousness is substrate dependent, uploading fails even in principle. Achieving heat death survival. Some physicists have speculated about structures that could survive heat death, cosmic scale intelligence operating on the energy of virtual particle fluctuations, or consciousness encoded in the structure of space-time itself. But these are deeply speculative. We have no idea if they're physically possible, let alone practically achievable. Reversing entropy, thermodynamically impossible. The second law is ironclad. Entropy increases. You can create local pockets of decreased entropy by expending energy, but the total entropy of the universe always increases. You cannot reverse the overall trend. Escaping the simulation. If we're in a simulation, escaping requires access to the substrate running the simulation. We have no mechanism to access that substrate. We're confined to the simulation's rules. It's like asking a character in a video game to escape into the real world. The character is made of the game's code. It has no existence outside the game. Finding new physics. This is the last hope. Maybe there's something we don't understand about physics. Maybe at higher energies or in extreme conditions, new phenomena emerge that allow what currently seems impossible. Quantum mechanics was discovered this way. Relativity was discovered this way. Maybe there's another revolution coming, but here's the thing. Every revolution in physics has made the universe more constrained, not less. Newton's physics had no speed limit. Einstein introduced one. Classical physics assumed infinite precision. Quantum mechanics introduced uncertainty. Every time we understand nature better, we discover new limits, not new freedoms. The trend is toward more constraints, not fewer. The prison becomes more clearly defined with each advance in our understanding. The odds that future physics will liberate us rather than further confirming our confinement are low, and we should not bet our civilization's strategy on hope for miraculous new physics that violates everything we currently understand. The escape routes are closed. The walls are real. The prison is not a temporary misunderstanding that better science will dissolve. It's built into the structure of reality itself. Section 20. The anthropic principle, selected for imprisonment. Here's something that should disturb you more than anything else we've discussed. The prison might not be accidental. We might exist specifically because we're in a prison. This is the anthropic principle taken to its logical conclusion. The anthropic principle states that we observe a universe compatible with our existence because if the universe were incompatible with our existence, we wouldn't be here to observe it. It's an observational selection effect. But it goes deeper. The specific values of physical constants, the strength of gravity, the electromagnetic force, the mass of fundamental particles, are finely tuned to allow complex chemistry, stable stars, and ultimately life. Change any of these values by a few %, and life as we know it becomes impossible. Some physicists argue this fine-tuning is evidence of design or of a multiverse where every possible combination of constants exists. And we necessarily find ourselves in one that permits life. But there's another interpretation, one that's darker. What if the constraints that make the universe a prison are the same constraints that make life possible? Consider the speed of light. It's not just a barrier to exploration. It's also the speed at which causality propagates. It ensures that the universe has a consistent arrow of time, that cause precedes effect, that the laws of physics are stable across space. Without a finite speed limit, causality might not work consistently. The universe might be chaotic, unstable, unable to support complex structures like stars, planets, or brains. Consider the expansion of space. It's not just confining. It also ensures that the universe doesn't collapse back on itself. If space weren't expanding, gravity might cause the entire universe to contract into a singularity. The expansion, driven by dark energy, keeps the universe open and stable. Consider the arrow of time. It's not just a prison. It's what allows memory, learning, evolution, consciousness. Without increasing entropy, there would be no distinction between past and future. No cause and effect. No way for complex systems to form and persist. The walls of the prison might be necessary for life to exist. The constraints might be features, not bugs. The universe might be precisely calibrated to allow life while ensuring that life remains confined. Under this interpretation, we exist because we're in a prison. The prison is the condition of our existence. We are anthropically selected for imprisonment. This is not comforting. It suggests that the universe is structured such that consciousness emerges only in contexts where it cannot escape, cannot expand indefinitely, cannot avoid eventual termination. It's almost as if the universe is designed to create conscious beings, give them just enough capability to understand their situation, and then ensure they can never escape it. That's a level of cosmic irony that's hard to bear. But it might be the truth. Section 21. Acceptance and defiance. 2 responses to the prison. So we're trapped. The walls are real. They're multidimensional. They're inescapable. What do we do about it? There are 2 basic responses. Neither is right or wrong. Both are valid. Both have merit. The first response is acceptance. The prison is real. We cannot escape it. Therefore, we should stop fantasizing about cosmic expansion and focus on making our confinement meaningful. This means investing in Earth, in our civilization, in long-term sustainability, in creating beauty, knowledge, art, relationships, experiences that matter even though they're transient. It means accepting mortality, personal, civilizational, cosmic, and finding meaning within those bounds. The universe will end. That's okay. What matters is what we do in the time we have. This is the wisdom of limits. The recognition that constraint is not necessarily bad, that boundaries can focus effort, that scarcity creates value, that mortality gives weight to our choices. Under this framework, the prison is not a tragedy. It's the condition of existence, and existence within bounds can still be good, still be worth experiencing, still matter deeply, even if it doesn't last forever. The second response is defiance. The walls are real. We cannot escape them. Therefore, we should push against them as hard as possible. This means investing in space exploration, even knowing we'll never reach other galaxies. It means pursuing radical life extension, even knowing we can't achieve immortality. It means building the most sophisticated civilization we can, even knowing it will eventually end. It means refusing to accept limits gracefully. If the universe is a prison, we should at least explore every corner of our cell. We should see how far we can go before the walls stop us. We should make the universe work for our continued existence and flourishing, extracting every possible second of existence, every possible increment of knowledge, every possible experience before heat, death claims everything. This is the spirit of rebellion, the recognition that even if we cannot win, we can fight, that the struggle itself has meaning, that consciousness pushing against the boundaries of what's possible is beautiful, even if it ultimately fails. Both responses are legitimate. Both have been articulated by serious thinkers across philosophy, science, and literature. I suspect most of us will oscillate between them, sometimes accepting, sometimes defying, sometimes finding peace in the boundedness of existence, sometimes raging against the dying of the light. The prison is real, but how we relate to it, whether with acceptance or defiance, is the last freedom we have. Section 22. The digital prison. Why virtual reality isn't escape. There's one more proposed escape route we need to examine, one that's become increasingly popular in recent decades as virtual reality technology has advanced. The idea goes like this. If we can't explore the physical universe, why not create our own universes? Why not retreat into virtual worlds of unlimited possibility? This is the dream of digital transcendence. Upload your consciousness to a computer. Live in a simulated world where the laws of physics are whatever you want them to be. Travel faster than light. Live forever. Escape the constraints of the physical universe by abandoning it entirely for a computational one. It's appealing, and it might be technically achievable within a few centuries, assuming consciousness can be digitized and run on computational substrate. But here's the problem. The virtual world still runs on physical hardware, and that hardware is still subject to the laws of physics. The prison doesn't disappear, it just changes form. Your virtual universe needs energy, lots of it. Running a detailed simulation of a conscious being requires enormous computational power. Multiply that by billions of uploaded minds, and you need energy resources on the scale of a Dyson sphere or beyond. Where does that energy come from? Stars? And stars burn out. Your virtual universe is sustained by the same stellar energy that sustains the physical universe. When the stars die, your server farms go dark. Your virtual worlds end. You might argue, we'll survive on black hole evaporation, or vacuum fluctuations, or some other exotic energy source? Maybe. But those energy sources are even more limited than stellar fusion. You'd need to reduce the complexity of your simulations dramatically. Simpler worlds, simpler consciousness, less experience packed into longer time spans. Eventually, you hit the same wall: heat death. The physical substrate running your virtual world is subject to thermodynamics. Entropy increases. Energy becomes less available. The simulation slows, degrades, eventually stops. There's another problem. The simulation has to be somewhere. It has to occupy physical space. And physical space is expanding. If your simulation is distributed across multiple locations, say, across a galaxy, to reduce a risk from any single point of failure, then the expansion of space eventually makes communication between those nodes impossible. Parts of your simulation become causally disconnected from other parts. The virtual world fragments. Minds that were once part of a unified simulation become isolated in separate, non-communicating segments. The prison reappears, this time in the form of light speed lag and cosmic expansion affecting your distributed servers. And there's a philosophical problem. Is living in a virtual world really escape? You're still experiencing time in one direction. You're still mortal. Your simulation can be turned off or corrupted. You're still confined to the computational resources available. You've just traded one set of constraints for another. The virtual world gives you more freedom than the physical one in some ways. You can ignore gravity. You can visit impossible landscapes. You can interact with simulated beings or other uploaded minds without physical travel. But you haven't escaped the prison. You've just moved to a different wing. One that's perhaps more comfortable, but ultimately still bounded by physics. The hardware decays. The energy runs out. The simulation ends. And you end with it. Virtual reality is not transcendence. It's accommodation. It's making the best of your confinement by creating artificial experiences within the confines of what physics allows. It might be a good strategy. It might make existence more bearable or more interesting. But it's not escape. The prison follows you into the digital realm, because the digital realm is built on top of the physical one, and the physical one is bound by laws you cannot break. Section 23, the generational prison trapped by mortality. Here's a dimension of the prison that's more personal and perhaps more painful. Even if humanity somehow escaped all the other constraints, even if we found faster than light travel, infinite energy, a way to survive heat death, you personally are still trapped by mortality. You will die long before any of these cosmic scale problems become relevant. Long before the stars burn out or the universe undergoes heat death. The average human lifespan is about 80 years. Let's be generous and assume you live to 100. That's still a cosmic eye blink. The universe is 13.8 billion years old. If the universe's lifetime were compressed into a single year, your entire existence would last less than 1/5 of a second. You are trapped in time. You get one brief flicker of consciousness in the vast stretch of cosmic history. You won't see how humanity's story ends. You won't know if we ever reach other stars or solve the mysteries of dark matter and dark energy. You won't witness the far future, and you cannot extend your lifespan indefinitely. We've discussed the biological limits. Aging is encoded in our cells at multiple levels. Telomeres shorten with each cell division. DNA accumulates damage. Proteins misfold. cancer risk increases exponentially with time. We might add a few decades with better medicine, conceivably a century or two with radical interventions. But true immortality, living for thousands or millions of years, would require completely re-engineering human biology. At which point, are you still human? Are you still you? There's a thought experiment called the Ship of Theseus. If you replace every part of a ship over time, is it still the same ship? If you replace every cell in your body, every neuron in your brain, are you still the same person? Life extension through cellular replacement might preserve the pattern of who you are, but it wouldn't preserve the physical continuity. You would be a copy, updated version by version, until nothing of the original biological substrate remained. And even if that worked, even if you could live for millennia through continuous self-renewal, you'd still be trapped. Trapped in the present moment. Trapped in one timeline, unable to visit the past or skip to the future. Trapped in the confines of a single consciousness that cannot directly merge with others or split into multiple simultaneous experiences. You are imprisoned in your own mortality and in your own singular identity. You get one life, one perspective, one thread of experience through time. This is perhaps the most absolute prison of all. Because even if humanity solves every cosmic constraint, you won't be there to see it. Your personal prison sentence is measured in decades, not billions of years. The universe might be eternal or might end in heat death. But either way, you will end long before it does, and that ending is approaching. Every second that passes is one less second you have. The walls of your personal prison are closing in at a rate of 1 second per second, and there is no escape from that. Section 24, the philosophical prison, can't know ultimate truth. Let me introduce one final dimension of the prison, the epistemological one. The limits not on where you can go or how long you can live, but on what you can know. There are questions about the universe that might be fundamentally unanswerable. Not because we lack the technology or intelligence to answer them, but because the structure of reality itself prevents us from accessing certain truths. Consider the question, what came before the Big Bang? Our current physics suggests that time itself began with the Big Bang. Asking what came before is like asking what's north of the North Pole. The question might be malformed. There might be no before because time didn't exist yet. But maybe something did exist before. Maybe there was a previous universe that collapsed and rebounded. Maybe our universe is one bubble in an eternal multiverse. Maybe there's some larger context we're embedded in. We cannot know. The Big Bang creates an information horizon. Everything that happened before, if that concept even applies, is causally disconnected from us. The evidence was erased or never existed. We are cut off from that knowledge by the structure of space-time itself. Or consider the question, is the universe finite or infinite? We can measure the observable universe, about 93 billion light-years across. But is that all there is? Does space continue beyond what we can see? If the universe is infinite, we can never confirm it. We can only see a finite portion. There's always more beyond our horizon. If it's finite, we might never reach the edge because of cosmic expansion. The question might be fundamentally undecidable from our position within the universe. There's a deeper issue too. Gödel's incompleteness theorems prove that any sufficiently complex logical system contains statements that are true but unprovable within that system. This is a mathematical result, but it has philosophical implications. If the universe is a kind of computational or logical structure, as some physicists suggest, then there might be truths about the universe that are real but unprovable by any being within that universe. Facts we can never access. Questions we can never answer, not because we're not clever enough, but because we're inside the system we're trying to understand. This is an epistemological prison, a limit on knowledge itself. No matter how advanced we become, no matter how sophisticated our instruments or our theories, there will always be a horizon beyond which we cannot see, truths we cannot access, questions we cannot answer. We are trapped not just in space and time, but in ignorance. Fundamental, inescapable ignorance about the ultimate nature of reality. And this might be the cruelest dimension of the prison, because humans crave understanding. We want to know how things work, why they are the way they are, what the fundamental truth is. And the universe might be structured such that we can never know. We can learn more, always more, asymptotically approaching complete understanding, but never reaching it. Forever confined to partial knowledge, uncertainty, and the awareness that there are truths just beyond our grasp that will remain beyond our grasp forever. The prison has intellectual bars as well as physical ones, and they might be just as unbreakable. Conclusion. So here's where we are. The universe is a prison, not metaphorically, literally. We are confined by the speed of light, by the expansion of space, by the arrow of time, by quantum uncertainty, by thermodynamics, by the structure of consciousness itself. The walls exist at every scale, from the Planck length to the cosmic horizon, from the quantum no-cloning theorem to the heat-death of the universe, from the limits of human biology to the mathematics of exponential costs. We cannot escape. We cannot even explore more than a tiny fraction of what exists. Most of the universe is receding from us faster than we can ever catch up. Most of time stretches infinitely ahead into a future we cannot survive. Most of reality operates at scales too small or too large for us to access. We are bounded beings in a bounded cosmos, and the bounds are absolute. This is not pessimism. This is physics. This is what the equations tell us. This is what the observations confirm. But here's the thing. Knowing you're in a prison doesn't make existence meaningless. It might make it more precious. If this is all we get, this brief flicker of consciousness in a vast, cold, indifferent cosmos, then maybe we should value it more, not less. The universe doesn't owe us infinity. It doesn't owe us escape. It doesn't owe us anything. The fact that we exist at all, that the universe permits conscious beings to emerge and ask questions about their own confinement, is already extraordinary. We can rage against the prison. We can push against its walls, test its limits, see how far we can go before physics stops us. That's noble. Or we can accept it, make peace with our confinement, focus on making the cell beautiful, making our time here meaningful, making the most of the bounded existence we have. That's noble too. Either way, we're trapped. The universe is a prison. The bars are made of the fundamental constants of nature. The walls are the horizons of space and time. The sentence is life, followed by heat, death, followed by eternal silence. But we're here, now, conscious, capable of understanding our situation, capable of making choices about how we respond to it. that might be the only freedom the universe allows. Not freedom to escape, but freedom to choose our relationship to the inescapable. If you made it this far, thank you for confronting these ideas with me. They're not comfortable, they're not uplifting, but they're true, as far as our best current physics can tell us. Drop a comment and let me know. Does knowing about the prison change how you think about your life, about humanity's future, about what matters? And are you team acceptance or team defiance? I'll see you in the next video. From inside the prison, because there's nowhere else to be. Stay curious, stay defiant, or stay at peace. Whichever works for you. The walls are real either way.